Anyone who's gone to sea knows that when you're at the dock, it's just a fundamentally different culture. When you get on that boat, you get onto the water, you become more a part of the ocean. And more in tune with it, and it just changed the perception and philosophy of everything.
Pilot, dive super.
Go ahead, dive super.
Let's descend at 15 meters a minute, hold at 50.
Good copy. Coming down.
Typically on the Okeanos Explorer, typically NOAA Ocean Exploration, we're leading remotely operated vehicle expeditions and mapping expeditions. We've dialed in telepresence exploration where we're connecting with folks on shore, where we're connecting with folks on the ship. We're streaming our video to shore, we're streaming our data to shore. We're using the latest in ocean mapping technology. We're always making improvements to our remotely operated vehicle system. And we need to think about what ocean exploration looks like 5 years from now. Maybe not next year, maybe not on this cruise, but down the line, we're working towards those goals.
The constant forward moving of technology is really important to the science. I mean, innovation is how we move forward.
Technology demonstration allows us a little room to breathe. It allows us to try out some new technology and see how they work on the field.
We are attempting to do a magnetic calibration of the compass that is inside of Orpheus, which will allow us, when we're underneath the water, to know whether we're going north, south, east, or west.
This Orpheus class vehicle is the only class I know of that's designed to sit down and sense the seafloor. Take push cores of the sediment, sense something, send an oxygen sensor down in the sediment and see if there's oxygen there, who's respiring there, take a sample. Who's doing that kind of work that's forefront? Well, NASA Jet Propulsion Lab has got this terrain-related navigation software that stitches things together, makes it 3D, and makes a feature map. And that same software is in the Ingenuity helicopter, it's in the Perseverance rover. So that's how the rover landed. It took pictures on the way in.
All right, coming up, give it up.
We have fed off each other in our knowledge of oceanography. We give them knowledge of oceanography. They give us technology and software that we never thought we could have, and it's just the melding of the minds. It's not just the hard bolts and nuts that's the technology, right? It's the imagination and the ingenuity that comes from these engineers that makes this so important. If we lose a vehicle, or we lose part of a vehicle, we lose the navigation system software, crashes and doesn't work, and we got to start all over again, then that's what we'll have to do. You didn't stop painting the Sistine Chapel because it got hard, or it got hot, or we ran out of paint, right? You have to keep going. And it's the passion that has to keep you going. It's a commitment. To be here with these vehicles now, this is another one of our benchmarks, right? In the phased design, construction, operation of these vehicles, here's another benchmark. This is where you want to be. Being on the water is the place to be. This is where we really learn, we test things. We need this time on the ocean.
Legs in the water. Good release.